So hello students, welcome once again to our YouTube channel. Please do subscribe the channel and like and share the video if they are useful. So that's the question from quadratic equation or theory of equation for you today. See, we have to solve this, rather we have to find all the values of an unknown involved in this inequality such that this inequality holds true for all x belonging to R. Now, just by looking at the expression in LHS, you all would have come to know that we will be replacing 3 raised to the power x by t, and the moment we replace it 3 raised to the power x by t, we get a quadratic in t. Okay, so what do we get? So this implies we get here a t square plus 4 times a minus 1 into t plus a minus 1 is greater than 0. Now that's the statement. But this inequality holds true for all x belonging to R. Now, what's the parameter or what's the variable here? Not the parameter. What's the variable here for this inequality now? The variable is true. Now, will we write the same statement for t also? That is this statement to be true for all t? Answer is no. Why? Because see, whenever we replace a function by a variable, whenever we replace a function by a variable, we need to take care of the restrictions of the function, like the range of the function here. Okay, so we know that exponential function is always positive. So the moment we replace c raised power x by t, we will say that here t should be greater than 0. So therefore, the valid statement now is for all t belonging to positive number or the positive real number. Okay, so for all positive t, now this statement has to be true, because for all x, 3 raised power x is going to be greater than 0. Now that's it. Okay, now the first thing, for all positive t, if this inequality has to hold, the quadratic inequality has to hold. According to me, we have two situations here. One is, of course, it's an open upward quadratic and d is negative. So a being the leading coefficient, which coincidentally is a here also, but we know we are referring here to the standard quadratic form ax square plus bx plus c. Okay, so if the leading coefficient is positive and d is negative, in that case the quadratic is always positive. So if it's always positive, it's positive for t greater than 0 also. Clear? Okay, or the second situation could be that if we talk in terms of quadratic in t, then the roots of the quadratic should be, both roots should be negative. Okay, then also for positive t, the curve will be above the t axis or the x axis. Of course, this is t axis because variable is t here. Okay, so that's the situation. Or you can say the extreme possibility is it passes through the origin and the other root is negative. So these are two situations. Okay, so let's take up the first one. First one, the leading coefficient is a, which has to be positive, and in both the cases actually a has to be positive, because if a is negative, then it's an open downward quadratic. Open down quadratic can't be positive for any large range of t. I mean, like any positive for all positive t or for all negative t or for all t, not possible at all. So the first point is it has to be an open upward quadratic. Okay, so a has to be positive. Now let's get d here. So d will be b square minus 4ac. So now d is b square 16 times a minus 1 whole square minus 4a times a minus 1. This should be negative. I think that's what we will get here. 16 times a minus 1 whole square minus 4a times, right? Now what? So 4 we can remove because we have to solve inequality. 4 is always positive, and we can take a minus 1 as a common factor. So you get 4a minus 4 minus a should be less than 0. So a minus 1 into 3a minus 4 should be less than 0. Now look at this. Now look at this inequality. Now the left hand side is again a quadratic in A. Now this is a quadratic in A, open upward quadratic in A. Why? Because the coefficient of A in both the factors are positive. Okay, so for open upward quadratic to be negative, The variable should lie between the roots, yes or no? And for open upward quadratic to be positive, the variable should lie beyond the roots, bachcho. Now here we need it to be negative, so this implies a should lie between the roots, and the roots are 1 and 4 by 3, so 1 2 4 by 3. That's first condition here. Okay, so this is what we get when we use this situation or this condition. Now moving to the second one, when it has real roots but both the roots are non-negative. Okay, so moving to the second condition where we have both the roots, so now to have both the roots, d can be greater than or equal to 0, and since the roots have to be non-negative, non-positive, okay, non-positive, so the vertex should lie on the negative side. Now the vertex of coordinate is at t is equal to minus b by 2a, this should be negative, and b is there 4 times a minus 1 upon 2a minus time should be negative. So that means what do we get? 2 times a minus 1 by a should be positive. Again, if you have two linear factors in ratio or two linear factors as product, the rule goes as it is. What is the rule? The rule which we use here. Okay, because the logic is same. Two factors are positive in product or ratio when either both are positive or both are negative. Okay, so the rule is same here again. If the coefficient of both the terms, both the factors of a are positive, then it will be positive beyond the root. So beyond the root means a should be greater than 1, and a can be less than 0 also, but of course we have already considered a to be greater than 0, a can't be less than 0. Okay, so that's the situation for the vertex to lie on the left side of the origin. Now let's solve for d. We already got on the previous slide. So what was that? It was a minus 1 into 3a minus 4, and this should be greater than equal to 0. Now again, either a should be less, see again, greater than 0 means beyond the root, so greater than the greater root, so larger root, or smaller than the smaller root. So that's the situation here. Okay, and f of 0, of course, for this situation, f of 0 should be either greater than or equal to 0. Now f of 0 here is, so if we replace t by 0 here, where is it gone? T by 0 here, f of 0 is a minus 1. So a minus 1 should be greater than equal to 0. So a should be greater than or equal to 1. Now we have to take the intersection, this one, and this one. Okay. So it's of course a is greater than equal to 4 by 3 is the intersection, and we already have a goes from 1 to 4 by 3. Okay, so therefore it's a either or situation. Either we will be considering this condition or this condition. So either or means we will be taking union here. So either a belongs to 1 to 4 by 3 union. So we can write 1 to infinity here. Now one case is, can 1a be 1 here? That we can check directly. Okay, put a is equal to 1 here. So t square is greater than 0 for all t. So we will include 1 also. Okay, shall I repeat? Put a is equal to 1 here. This is 0, this is 0. You simply got a into t square is greater than 0 since a is positive. So that's always true. So if it's always true, it's true for t positive also. So that means I'll be including 1 here. So according to me, that should be the final answer. Okay, so that was a question where we used the entire that curve part of quadratic, bachcho, okay, to solve such type of equation. So I believe this question will be helpful in, see, the important point was using this condition and then accordingly changing the statement of the inequality and then using quadratic part. Okay, so that was the question for today, bachcho.